Hey my warriors, welcome to the legendary series. I hope I'm audible and visible. Do let me know in the chat box. Hello Legend Prachi, hello Niharika, hello Akula, hello Harun D Rocky. Welcome guys, welcome all my lovely warriors. And today's chapter is vectors. So those of you who do not know, I have been doing this legend series which is for the 2-year course students, both for JEE as well as NEET, and yes, of course in English. And this is basically a long-term series which is meant to complement the previous year's nurture series. So last year I conducted nurture where I completed the entire syllabus on YouTube, and you can see that playlist, it's readily there. So these lectures will help you in addition to that to cover and understand the topics in a better way. All right, so we are going to see vectors and especially the vector addition and subtraction part, the application part of it in today's session. So stay tuned till the end. Do not forget to smash the like and the subscribe button. With me Shreyas, your physics master teacher at Vedantu, and I'm going live. Hello, good evening all my lovely warriors. It's very important that you hit like as well as subscribe, because only when you do that I will get the motivation to conduct more classes. Come on guys, you have to do that. Okay, so Harun, I think, okay, Harun says that I'm not taking classes regularly. Okay, Harun, let me show you. Okay, see this. This is JEE advanced session yesterday. Before that, this. Before that, this. Before that, where is it? This. Okay, every day you will see my lecture. Obviously, Saturday, Sunday, don't expect me to take classes every time. Okay, but yeah, you can see every day. So please tell me, bacha, where am I not taking classes every day? So either something is not loading or check your internet. Good evening, everyone. Hello A Singh, hello Anushka, hello Joyce, hello Rashmi, Yagna, welcome Priyanka, welcome Arumungan, welcome Niharika, good evening. Legend series, obviously Harun, I will not take the lecture series every day. That is understood, right? Because there is 11th standard student, there is 12th standard student, there is passing out student. What do you expect me to do? Take 11th and 12th and advanced 3 lectures in one day? Not possible, sorry. Okay, so, yep. So that is how it is going to be. Hello Khushi, hello Freezer, hello Mukalim, hello Arumungaran. Welcome guys. So let's begin with the class and let's start with the lecture. And here it goes. Let's start with what is the meaning of vector. Vector is nothing but a quantity which has both magnitude and direction, and quantities like velocities, acceleration, force, momentum, all these are vector quantities. But things like maybe distance or time or area or volume or pressure, these are basically things like scalars, right? So how do you represent a vector quantity and what is the way of writing a vector? Please see this, very very important. I'm just revising the topics briefly before we go to the vector addition part, so stay with me really quick. We'll do this. So if I show a vector like this, let's say this is some velocity vector. Let's say it goes from point O to point A. The arrow marks length. The length of this tells me the magnitude. The length tells me the magnitude of that vector, and the vector itself I can write. Let's say for example it's velocity. The velocity vector is nothing but OA vector. Also some books use a bold symbol. This is basically bold. So you can use a bold notation to represent a vector quantity. This point is basically your tail. This is nothing but your head. Head, tail, tail, head. It shows the direction in which it is going. So this is the vector notation. You can also write the magnitude of it by putting modulus symbol. So if I put modulus like this, or just OA vector modulus, or you can just put V without bold. This is bold letters. This is just plain font. Then it represents basically the magnitude or basically the length of it. Magnitude or the length of the vector quantity. This is something which everybody knows. Now we have something called as the unit vectors, which helps us write the vectors in a much better way. So what exactly is a unit vector? Unit vector is a vector whose magnitude is nothing but 1. If I tell Rashmi walks 1 kilometer in the east direction, so Rashmi's displacement is a unit vector. If I say Sai Karan Gaud Bura has moved with 1 meter per second in the north direction, so his velocity is also a unit vector. Great. And the best way to say that a vector is a unit vector is by writing this one. Look at this. Just put any vector and put a hat over it or a cap over it. When it's sunny, you wear a cap or a hat. So put a hat over it. Then that is the way you represent a unit vector. The magnitude of any vector with a hat is always going to be 1. That cap or that hat is very, very important. Now there are very special unit vectors which you need to know. One is along the x-axis, y, and then the z. Those special unit vectors are shown over here. So I hat, j hat, k hat are special. Like you have special pav bhaji, special chai, special coffee. These are special unit vectors along obviously x, y and z axis respectively. Very, very crucial. Why? I will tell you. Imagine who is there over here? Vansh. Good evening, bacha. Imagine Vansh has traveled, 5 kilometers along the x-axis. If Vansh travels 5 kilometers along the x-axis, I will say Vansh's displacement is 5 times of I cap. 5 times of I cap. I cap, 5 I cap. If example, Priyanka flies in the air 10 kilometers up, so she's, let's say, going in the y-axis, I will say Priyanka's displacement is 10 j cap. So it helps me write the vector in a much better way. I hope you guys see that. Great. Now what happens is that whenever you talk about these unit vectors, usually we are generally describing I, j, k, which are those special vectors. But let's say some other direction is there, then you will generally show some other symbol, some weird direction. Maybe it is in some 3D direction. Then you will not use I, j, k, then you will use some random other symbol. So how do you exactly show the vectors in 2D or 3D? How do you exactly show the vectors in 2D or 3D? Imagine somebody is applying some force. Let's say Khushi is pushing something she is lifting, applying a force like this. I can say that Khushi is applying a force in an angle, but that force has 2 components. One component here, another component here. Component is nothing but a part of something. Like a car has component. You are also made of components. Any device has component. So any vector also has components. Something in x, something in y, something in z. These are the components. So this force will have certain components. Like you can see right over here, there is an x component. In this case, if this is theta, you can see this will be f cos theta, because I know why this comes, because cos of theta is in this triangle adjacent by hypotenuse. So adjacent is fx, hypotenuse is f. So if you shift f over here, you will get this. This is the x directions component of that force which Khushi has applied. Similarly, this force will also have some y-axis component, and this fy will be, in this case, f sine theta. I know where this comes from, because sine theta is opposite side, which is also fy, divided by hypotenuse, which is f. This is how it comes. So when any vector is in 2D space, it generally has 2 components, one in x, one in y, and that force can be now represented as the sum of the x component plus the y component. These are basically the components of a vector. Components, parts of a vector. Fx will be how much magnitude is there in x, I cap, and fy will be how much magnitude is there in y, j cap. So fx in this case is f cos theta. This is I cap. Fy is nothing but f sin theta j cap, right? So that is what the force is. It could be anything. You will substitute the values and you will get it. Everybody with me on this? Everybody with me on this? Awesome. Sir, did the physics syllabus just started or any chapters covered? Khairuddin Majula, yes, some chapters were covered. If you just open up the past videos, no, whichever has the word legend, those are the parts which are covered. I have done things like units and dimensions errors, basic maths graphs have done, kinematics 1D have done. So some things are also done over there. All right, great, legend, awesome, awesome guys. Now this is in 2D, but generally the vector may not be in 2D, it can have 3 components. So whenever you have a vector in 3D, I generally tell my students that please try to think of a cuboid or the room in which you are there, and one of the direction is x, one of the direction is y, one of the direction is z. It becomes very easy to remember, or not remember, actually visualize that vector. Like for example, somebody says that this is my origin, somebody says that this is my origin. This side becomes, let's say for example, your x-axis, this side vertical becomes, let's say, your y-axis, and this side, which is coming out of the plane of the board, becomes your z-axis. So imagine I have to draw a vector in 3D, so probably I will start from this corner, I will go till this corner, this diagonal, which is going from one vertex to the another vertex. So this is my vector. I hope you can visualize it. It is going from one corner to the other corner, and this vector will obviously have its 3 components. One component over here, this will be called Vx. Then you will also have one component over here, which will be obviously Vz component, and this component is nothing but your y component. So our vector V is technically made of Vx I plus Vy j and Vz k. These are your 3 components in x, y and z direction. I hope everybody is understanding and able to visualize it. So whenever you see a room, you should always think of a vector. Oh, it is going like this. Oh, it is going like this. Oh, it is coming like that. Oh, it is going like that. So it's easier to visualize whenever you think of a room and join the corners of a room. So drawing a cuboid is very important. So this is a vector, but if you talk about the magnitude, of the vector, which is nothing but V bar's modulus, then what will it be? Guys, I'm pretty sure you have seen this formula back in your 9th or 10th grade. If you have a cuboid whose side lengths are length, B and H, L, B, H, length, breadth, height is given LVH, then the length of the diagonal is root of L square plus B square plus H square. So this is length, breadth, height. So the length of the diagonal will be nothing but root of L square plus B square plus H square. That means Vx square plus Vy square plus Vz square. This comes via Pythagoras also. Exactly. So I'll come to resultant, bacha. Joyce Mary legend, I'll be coming to it. So this is the magnitude of any vector. If one of the components is absent, one of the term will become 0. Okay. But if all the 3 components are there, in the most general case, this is how it will look like. So if I tell, for example, Joyce Mary, example, okay, this is just an example, guys. Imagine Joyce Mary has a displacement of 2i cap plus 3j cap minus k cap. Means he has gone 2 units in x, 3 units in y, and 1 unit behind in the opposite direction of z, along minus z. So the displacement magnitude will be root of 2 square plus 3 square plus 1 square. Even if it is minus, it will be plus. Be careful. So this will be nothing but 4 plus 9 plus 1, which is nothing but root of 14 units. So Joyce Mary has traveled 14 units in a weird direction. Something in x, something in y, something in minus z. This is how it works. Okay. Now that you understand the background of what a vector is, how you show it, now things will be much easier because some of you might have forgotten, or maybe somebody is very new to it. So now that we have laid the basics of how you show a vector, let's see what is the meaning of adding a vector. Let's see what is the meaning of subtracting a vector. Well, let's talk about adding. When do you add? When you want to take the cumulative effect. For example, Priyanka is pushing something. Vignesh is also pushing that same thing, furniture. Ragul is also pushing. Legend Prachi is also pushing. Joyce Mary is also pushing. Yogeshwari is also pushing. All these people are pushing a piece of big furniture. So together, each one, because they are applying the force, together they will be applying a resultant force. Resultant is the cumulative effect of all the things together. Correct. That is the meaning of resultant. Whenever you have to find the cumulative effect or the resultant or the sum or the combined value of many vectors, you use addition of vectors. And there are basic rules to add vectors. One is via pure geometry. Okay, Srinath also wants to join in. Okay, fine, Srinath, you also join in, bacha. Maybe I'll take you in subtraction. Okay, so imagine this. There are by the way, there are two ways of adding vectors. One is pure geometry via diagrams. The second one is via formulas. So I am going to start with geometrical methods first. Then we will go to calculative methods, or basically analytical methods or algebraic methods, whatever you want to call them. Let's start with geometrical methods. So how do you add them geometrically? Imagine, guys, these are the vectors that I want to add. This is one vector. This is one vector A. Then I want to add to it this vector B. Then I want to add to it this vector C. And let's say I want to add to it another vector, let's say D. What you need to do is, whenever you have to add vectors, you can take any vector in any order, start placing them one by one. Wherever the first vector ends, start the next vector. Wherever the next vector ends, start the next vector, and keep on joining them until you have run out of all the vectors. Then you will see that wherever you started and wherever you ended may not necessarily be at the same point. So there is some missing side of a big polygon. You just complete the polygon. That gives you the resultant vector. So here is how it goes. Take this vector as it is. You can slide any vector, but when you slide, do not tilt it or do not stretch it. Take it as it is. So I'm just going to take A as it is, guys. I'm going to take A as it is. This is vector A. Then I'm going to take B as it is. B is as it is over here. So this is your B. Okay, I'm just showing it. Okay, maybe I might tilt it a little bit because I'm not doing it exact, but I hope you get the idea. Then take vector C. Wherever B ends, start the next vector. So this is maybe your vector C. Okay, this is your vector C. Great. Now finally take vector D over here. Let's say this is vector D right over here. This is vector D. That's it. Done, done, done. Now always head, tail, head, tail, head, tail. No, it is always tail, head, tail, head, tail, head, not head, tail. Tail, head, tail, head, tail, head. That's how the order goes. Do you see there is a missing side? Do you see there is a missing side over here? To complete that polygon, now a lot of people think, should I go from here to here or should I go from here to here? This together will give you this vector. The starting position to the final position. Start, the tail to the head. This is your resultant vector. So I can just say the resultant vector is the combined effect of A vector plus B vector plus C vector plus D vector. This method of addition is often called as the polygon method of vector addition. This is called as the polygon method. This is something which you should definitely know. Now a lot of you might be thinking, sir, R vector is A vector plus B vector plus C vector plus D vector. Is R vector or R vector's magnitude also equal to A's magnitude plus B's magnitude plus C's magnitude plus D's magnitude? What do you guys say? Should I put an equal to over here? Yes or no? Yes or no? Come on, guys. No, you will not put equal to. This is not equal to. Guys, the reason for that is their lengths addition is not the resultant vector. This is like displacement. This plus this plus this plus this will give me from here to here. This is like displacement. It will not necessarily be the addition of all these lengths. So addition of all the lengths will give me distance, not displacement. Keep this in mind. Interesting? So this is called as the polygon method. Now somebody will be like, sir, you took A first. Who told you to take A first? Just because A comes before B and B comes before C? No, no. Even if you try the other way around, let's say I start with, let's say vector C first. Let's say I start with vector C first. Then let's say I go to vector A. Interesting. So vector A is here. And let's say then I go to B. Then I go to B. So B vector maybe slightly more at an angle. Okay, let's try to draw it. So this was A, this was your B, and then finally D, and then finally D over here. Still, if I join these points, this will still be R. Whatever R is here will be the same R over here. So it really doesn't matter. This is also equal to whatever I did over there. C vector plus A vector plus B vector plus D vector, and I can do all sorts of combinations over here, so on and so forth. So order does not matter. Whenever order does not matter, such a thing is called as commutativeness. Commutative. Commutative means order is not important. Whichever vector you feel like adding first, you add that first. Okay, why not opposite direction, Khushi? I'll tell you. Simple. Imagine, Khushi, this is your displacement. So Khushi, you traveled like this, then you traveled like this, then you traveled like this, then you traveled like this. If I ask you what is your total displacement, will you say it is this one, number one, or will you say it is that one? Number one is this, number two is this. Obviously, if you travel like this, like this, like this, like this, your displacement will be from here till here. So that is the resultant, not that way. I hope that makes sense. Great. Is that clear? Everybody with me on this? Okay, I have a question for you. What if by chance, this is just an example. Imagine somebody was drawing a polygon, drawing all the vectors like this. It went like this, it went like this, and the final vector just came onto the initial vector. What if it is like this? What do you guys say? What will happen if all the vectors add up in such a way that there is no missing element? In that case, the resultant will be 0, basically a null vector. It will be nothing but a null vector. They complete the polygon. So here you can see it is a complete the polygon. Complete the polygon. There is no missing side over here. Very, very important. Okay. Now, usually people learn triangle and parallelogram methods of vector addition. Let me tell you, it is actually a subset of polygon method, indirectly or directly. I'll tell you how. Maybe I can just add up a slide over here. Let me see, just one second. Let me create a blank slide. Okay, I think I have a blank slide. Okay, great. Now let me just write over here. Imagine I have just two vectors, okay? How many vectors? Only two vectors. So imagine I have a vector like this. This is A, and maybe this is vector B, and I want to add them. Now if I have to add them, one way I can do it is basically take the vector A as it is, take the vector B as it is, and put it over here. Put this vector B over here. If I add these two, I get this vector like this. This is my resultant. So this resultant is nothing but this vector A plus vector B. Isn't this polygon method of a vector addition? Isn't this polygon method of vector addition? But just that now we have two sides. So when I have two sides, this polygon becomes a triangle. So usually this is also called as the triangle method of vector addition. This is also called as the triangle method of vector addition. So it's nothing different from the polygon, just that a polygon with total number of 3 sides, it becomes a triangle. Is that clear? Okay, everybody with me? Thank you, Vignesh, so much. Now, I will show you one interesting thing. What if I show that vector A. I show that vector A as it is. This is vector B, obviously. Now what if I take that B and slide it over here? I take that vector B and slide it over here. Take this vector A and slide it over here. This is vector A. What is it becoming, guys? Come on, put it up in the chat box. Good evening, Nadila, Mandis. What do you think this is coming out to be? A. I just took this B, slid it over here, took this A, slid it over there. What do you think this is turning out to be? Obviously, it's a parallelogram, right? Now, the resultant was here. Just put it over here. The resultant was here as it is. You know, it's actually triangle law both ways. If you go from this side, it is actually speaking, from this side, it is A bar plus B bar. If you go from this side, it is B bar first and then A bar. So that is what is parallelogram law. All you need to do is whichever vectors you want to add, whichever vectors you want to, oops, my God, one second. Whichever vectors you want to add, just show the vectors starting from the same point, and just complete a beautiful parallelogram. And from their common vertex, just show the resultant. So this is often known as parallelogram method of vector addition. So you will be like, sir, which is correct, sir, which is wrong? Come on, you only have to answer that. Which method is correct, which method is wrong? You only have to think and answer it. Obviously, doesn't really matter. It's one and the same thing. In fact, this came from Polygon, and triangle via both these triangles becomes a parallelogram. So this is actually coming from this. This is coming from this. So at the end of the day, all are same thing. It's just a different perspective. It's like the two sides of the same coin. Everybody with me? Shruti, see me solve the numericals. See my Nurture, my Pathfinder, as well as Legend, as well as Ultra Legend series. I promise you, if you follow my lectures, solve the homework, solve the assignments, solve the modules, practice on your own, solve PYQs, give mock tests, nobody can stop you. Scale up slowly from 0 to hero. Okay? Everything is correct. Excellent. Awesome. How about solving some questions? But before that, I will teach you subtraction. Everybody ready to learn subtraction? Everybody ready to learn subtraction before we go to problems? Look at this, adding these vectors using parallelogram law or triangle law, whatever you want to do. Always take the forces or velocities or acceleration, just slide them one after the other. Beautiful simulation of how to add vectors. Look at this, tail head. The missing side always becomes the resultant vector. See it once more before we go to the subtraction part. Thank you guys for lighting up the chat box, means a lot. Thank you for smashing the like button also, it means a lot. Let's talk about subtraction. Okay. Let's say somebody tells, Captain Shreyas sir has moved 5 units to the right direction. So 5 units. 1, 2, 3, 4, 5. Captain Shreyas sir also moved 2 units towards the right side. 1, 2. So 1, 2, 3, 4, 5. 1, 2. Totally, how much did I move on the number line? 7 units. 5 plus 2, 7 units. Everybody with me on this? Great. Now, somebody says, Captain Shreyas sir moved 5 units in the right side. 1, 2, 3, 4, 5. Captain Shreyas sir moved minus 2 units towards the right side. What does that mean? Captain Shreyas sir moved minus 2 units towards the right side means I have moved 2 units behind. So how much did I move front? I moved 3 units in the front, right? I moved 3 units in the front. So subtraction is nothing but addition of a negative number. If this enters your head, nobody can stop you from learning subtraction the easier way. So subtraction is nothing great. It is nothing but the addition of vectors. So it is nothing but vector addition with a negative vector. So I will show this to you. Imagine somebody says, I have to find the subtraction of the vector a minus b. it is as good as saying it is A vector plus the negative of B vector. So whatever you learned there is applicable here. Whatever you learned there is applicable here. That's it. There's nothing great, just that whatever the second vector is, flip it. Take the negative of it. Oh, but there is one interesting thing. Notice that if this subtraction is A bar minus B bar, and if somebody says also try to find this one maybe, how about this S prime? S prime is B vector minus A vector, which is B vector plus negative of A vector. Do you think S prime and S are equal or not equal? Do you think S vector and S prime vector, A minus B and B minus A, are they equal or not equal? Just answer that question. Isn't it obvious? This is A minus B, that is B minus A. Magnitude wise may be equal, direction wise, sign wise they will not be equal. So in fact from here you can clearly tell that guys, A bar minus B bar is definitely not equal to B bar minus A bar. But magnitude wise, direction wise they are not equal. So magnitude wise they are definitely equal. Magnitude wise they are definitely equal. Direction wise opposite, vector wise not equal, magnitude wise equal. That's how it works. Great. So let's see how do we draw them. Imagine somebody gives me two vectors. Somebody gives me vector A and somebody also gives me vector B. The first thing, let's say I want to find S bar, A plus negative of B. So I will draw A vector first. And negative of B. So whatever B is, flip it. So if I flip it, I will get the negative of B. This is negative of B. So I just have to add both of them. Just like the previous one, polygon, triangle, parallelogram, doesn't really matter. So this is your subtracted vector, A vector minus B vector. I hope everybody can see this. Okay, I hope this is clear. Similarly, oh no, it is not commutative. Here it is not commutative. Commutative means order does not matter. Whatever order is there does not matter. Here, subtraction order matters, so it is definitely not commutative. Similarly, if I try to find this one, B minus A, so take B vector as it is. This is your B vector minus A. So whatever A is, flip it. Wherever A is there, just flip it. So minus A vector. This is minus A vector. So this one over here will be S prime vector. That's all. So this and this will be opposite. I have not drawn it to scale, so please excuse me for that. But yes, if you draw it properly, measuring the angles, it will turn out to be perfectly fine. So you can see they are definitely not the same vectors, at least the direction wise. Yep. Subtraction is not, addition is commutative. Very good, Legend Prachi. Shall we now solve problems? Because now you guys understood what is vector subtraction. Like you can see right over here, F vector and F2 vector, if I want to subtract them, flip the vector and then add it normally like you would do. That's it. Observe this carefully again. Observe this. Ready for problems? If you are ready for problems, just put up a thumbs up in the chat box. I'm going to start with the problems. Meanwhile, you can just have a look at the animation. This is vector subtraction. Also needed many times whenever you have to find changes in any quantity. When do you subtract, guys? You subtract whenever you have to find how much is remaining or how much is the change in something. So that time you subtract. Earlier this much was there, now this much is there. So how much is the improvement? How much is the change? How much is the delta? So that time you use subtraction. Great. A vector is negative of minus A vector. Yeah. Okay, great. So let's start. Minimum number of vectors which are not equal in magnitude to add up to 0 is how much? How many vectors do you think you need? Come on, put up the answer in the chat box, all my lovely warriors. Do you need 2? Do you need 3? Do you need 4? Do you need any number of vectors? Awesome, Karthikeyan. Watching AI live also, watching YouTube also. Very good. Making use of all the best resources everywhere. Not leaving any stone unturned. Not taking any chances. Keep it up, guys. So what is the correct answer? Minimum number of vectors needed to unequal, by the way, to give a total sum of 0. So if I have, let's say, a vector like this, and if I take another vector, maybe like this, but it should not be of same magnitude. Oh, their sum is not 0 because there is a missing side. So I need one more vector over here to make their total sum 0. Or I can make a vector like this. I can make another vector like this. And I can make another vector like this. Great. So now also the polygon gets completed. The total sum is 0. So I think I need at least 3, not 2. Yeah, not 2. Definitely option B is correct. And looks like all my warriors are correct. Very good, Srinath. Very good, Tianjana, Joel. Awesome, Vishali, Yogeshwari. Awesome, guys. Very good. Keep it up. Moving on to the next one. A vector is added to an equal and opposite vector of similar nature. It forms unit vector, position vector, null vector, displacement vector. Interesting question. Interesting question. Let's see how many of you can do this. A vector is added to an equal and opposite vector of similar nature. So velocity added with velocity, but of equal magnitude and opposite direction. So what do you guys think will be the final answer, guys? Let me know in the chat box. Very good, Nadila. Very good, Janish. Come on, guys, for the next one. Come on. Jan saying C for this one. If you take a vector and add it to an equal and opposite vector, so if V1 and V2 are added, they are equal and opposite. So V1 bar plus V2 bar will be 0 bar, which is also called as null. Nothing will be there. Nothing will remain. Pandu is pushing here. Champa is pushing opposite. Tug of war between Pandu and Champa. Nothing will be remaining. Answer is a big fat 0, which is also called a null vector. Position vector is a vector which tells me the position of the particle. Displacement vector is the vector which tells me the displacement of that particle. Obviously, it is not displacement or position. It can't be unit. Answer is null. Okay, this is a beautiful question. Many students will definitely make some kind of mistake if you're not very observant. So think which vector plus which vector will give you F vector. F vector will be a combination of which of these two vectors, vector wise. Yes, Pandu and Champa. What is coplanar? Plane. You know a plane? So if things are in the same plane, they are coplanar. It could be points, it could be geometrical figures, it could be vectors. So if I say vectors are coplanar, that means everything is in the same plane. So if I draw like all these vectors, they are in the plane of the board. So these are all coplanar. If they are along the same line, one after the other, they are in the same line, that will be collinear vectors. I hope that is clear. N.A. Thananjayan. Okay. What do you guys say? Come on, my warriors. Come on. Let me know which of them is correct. If you go one by one also, you can get it. Many of you are saying D. Many of you are saying, some of you also saying C. Come on. Let's see if C is correct. D plus C is F. D plus C. Okay, this is D plus C will give me this one. Oh, definitely not F. D plus E, let's try that out. D plus E will be this one. Oh yes, this can be F. Definitely. So I think it should be option D, which is D plus E is F. Yes, it is. Yes, it is. Anything else will not give you the answer. B is not the correct one, bacha. B is not correct. B plus C. If you try B plus C, see B is down. B is down. Plus C will be here. In fact, you are going to get this. Although the line is similar, but arrow mark is different. In fact, it will give you minus F. In fact, it will give you negative of F, not the F vector. So be careful, it will not be B option. Okay, so moving on to another question. This is a brilliant question. Lovely, superb question. Okay, let's understand. Figure shows three vectors P, Q, R, where C is the midpoint of side AB of this big triangle. Which of the following vector relation is correct? P plus Q, P plus Q, P minus Q, P minus Q and R. I can see everything is got to do with P, Q and R. How can P, Q and R be related where C is the midpoint? Interesting. Maybe maybe I need to write some equations. Prasanna Lakshmi, it's called as an ultra legend series. That's this year's live classes. Last year's classes are called as Pathfinder. So it's all there in the playlist, just go with it, you will see it. Okay, so what will I do? Okay, how about looking at this beautiful triangle? Okay, just 1 second. This triangle. Oh, I can see R vector is here, P vector is here. Maybe I see a triangle. Maybe I can think of a forceful attempt of using triangle law forcefully. How about P vector and this AC vector? P and AC together give you R. Can you see the triangle law or polygon law? This vector plus this is this. So can I not say P vector plus AC vector is actually R vector? Everybody sees that. Directions are very important, arrow marks are very important. If you mess up the arrow marks, you will get a wrong answer. Okay, many of you are saying option A. I don't know. Let's find it out. How about this triangle? Beautiful. This is Q vector. Obviously, this is also R vector. And this is the incomplete side. Q plus this gives me this. Again, polygon law or triangle law, whichever you want to call. This plus this gives me the resultant. So how about writing Q vector plus BC vector is R vector? Obviously, I'm going to sit and add the two. And what am I going to get? I will get P vector plus Q vector plus AC vector minus BC vector is R vector plus R vector. So P vector plus Q vector is equal to 2R vector. AC minus BC. AC is here, BC is there. Guys, AC's magnitude is equal to BC. AC's magnitude is equal to BC, but they are opposite. What happens when you add two equal and opposite vectors? They will definitely cancel. In fact, we just did a numerical on this, so it will be 0. So hence P plus Q will be just simply put 2R. That's it. Done, done, done. I think option A is correcto. Yes, it is correcto. Amazingo. Sir, what lesson is this? What session is this? What lesson? Session, addition and subtraction of vectors. Lecture 1. Okay. Lesson, if you talk in NCERT, it is there in different chapters. Don't even ask. Like motion in 2D is there in so many chapters. Circular motion is there in so many chapters. So, okay. So that's probably going to be in motion in a plane. If you talk about H.C. Verma, it will be in a separate chapter called as vectors. Maybe if you look in some other book, it might be in basic maths. Who knows? So different books, different coachings will have different names. Name is not important. The concepts are important. Beautiful question. Moving on to the next one. Okay. If three vectors are in the same direction or in the same order and they are arranged in the form of a closed triangle, they're in the same direction, they can't be in the form of a triangle Tulika, then the resultant is 0 vector. If so, then why? Because if they are in the same order and they form a triangle, then there is no missing side. Be it triangle, be it a quadrilateral. A vector plus B vector plus C vector plus D vector plus E vector plus F vector comes back to the same point. It's like you traveled around the city and came back to the same point. It formed a closed loop. Khatam. That's it. Done, done, done. Moving on. It will become 0. Okay. Circular motion will take a long time. Bacha. Okay. At least next month. At least I'm saying, but it might go to October. If the magnitude of the sum of two vectors is equal to the magnitude of the difference of the two vectors, then the angle between the two vectors is. Come on, my warriors. Prachi saying 90 degrees, option A. I don't know. Somebody might say something else. Come on, my warriors. Figure this out. The sum of the two vectors is equal to the difference of the two vectors. So imagine there is a vector like this. Okay. And I add it to another vector. And I add it to this vector. So this becomes the resultant. This becomes the resultant, which is nothing but A vector plus B vector. Now the difference, that means the subtraction. So if I do A bar, negative of B bar will be exactly opposite to B, like this. This will be minus B bar. Everybody with me? So the difference will be basically this one. This is the subtraction or the difference, and this will be A vector minus B vector. As per the question, the magnitude of the sum and the difference is basically equal. It's clearly mentioned they are equal. That means this side is equal to this side. So what kind of a triangle does the big one become? It is an isosceles triangle. It is an isosceles triangle, and we all know that whenever you have an isosceles triangle and if you draw an altitude, what is this? An altitude. That altitude also divides that opposite side, equally. Basically, it also becomes, altitude also becomes the median of that triangle. And you can see, if it is a median, it will become an altitude. Now I can see this side and this side are equal, this and this. So I think it is the midpoint. Can you not see that, guys? This is basically the midpoint. If this is the midpoint, naturally this becomes the median. And if this is the median, it is also the altitude of the triangle. If it's the altitude, that means this should be 90 degrees. So A and B, the angle between them is 90 degrees. That's geometrically proven. No need of formulas. If you notice, I have not written even one single equation on the board. Many people try to solve this question with equations, but the beauty of this problem is you can solve it even with geometry of your 9th grade or even 10th grade. There you go. That's it. That's the answer. If you love this solution, make sure you have smashed the like button already. Great. Moving on to the next one. Oh, before I go to the next part, make sure that you have downloaded the Telegram app, and you have joined the Telegram channel either via scanning this or via the link in the description box. You will not be able to search our Telegram channel because it's very important to download the app and also join the channel, because you will get the updated notifications and also the PDF of today's class with handwritten solutions. Okay, so make sure you are a part of it. Now let's go to the second way, and the second way is also very important. Till now whatever we did was addition and subtraction of vectors via which method, guys? I know you will say, sir, polygon, triangle, parallelogram, whatever. That is called geometrical approach. Purely, we did not calculate anything. We use pure geometry, just geometry. Now the second approach, like I told you, is algebraic approach or analytical approach or formula based approach. So what is that approach going to look like? It's simple. In fact, you are going to love this also because it just involves some basic calculations. So imagine if somebody gives me a vector A and this is, let's say, vector B, and the angle between the two vectors is theta. So theta is basically the angle between A vector and B vector. Then the resultant vector is here. The length of that resultant vector is given by root of, this comes via Pythagoras and basic geometry. Don't worry about the derivation. It will be a square plus b square plus 2ab cos theta. I would have done the derivation back in nurture series, or you can join my derivation course in the pro subscription. I've done the derivations of all the chapters of 11th, 12th, everything. Okay, so a square plus b square plus 2ab cos theta's root will give me the length of the resultant. This is the first formula. Another formula which you should know is the angle which the resultant makes with the vector A. The angle which the resultant makes with the vector A. So that is basically alpha. And tan of alpha is just given by, b sine theta divided by a plus b cos theta. That is alpha. And similarly, whatever the resultant makes with vector B, that is beta, whatever the resultant makes with B vector, so I'll call it beta. So alpha is for A, beta is for B. So tan beta, very similar to this, instead of B sine theta, here you will have A sine theta, and here you will have A sine of theta, and instead of A plus B cos, here you will have B plus A cos theta. That's the formula. So if any time a question is asked on finding the magnitude of the resultant or find the angle of the resultant with any of the vectors, you will use one of these formulas. That's all. It's as simple as that. I think you will love this formula because just substitute and you will get the answer. This is one way, but there is even another way of approaching the same kind of question. Imagine, I'll just give an example. Pandu travels, first time his displacement is 2i cap minus 7j cap. Then second time Pandu travels 3i cap plus 2j cap. Then third time the Pandu travels minus I cap plus maybe, I don't know, 5j cap. So the question is, what is the total displacement of Pandu? What is the total displacement of Pandu? In such a case, if the total displacement is asked, all you have to do is just add the I displacements, just add the j displacements, if k is there, add the k displacements. It's just like thinking, when Pandu moves 2 units in x direction, he has moved 2 units in x, then he moved 3 units in x, then he has moved 1 unit back in negative x. So basically add the x's, add the y's, add the z's separately. That's all. So Sujata, the tan beta comes just by looking at the tan alpha value. If alpha had b and then a plus b cos, then beta will have a and then b plus a cos. It's just by symmetry of variables. That's all. So 2, 3 and minus 1, that is just going to give you 2 plus 3 is 5, 5 minus 1 is nothing but 4i cap. And here 2 plus 5 is 7. Oh, everything cancels. The final answer is just 4i cap. So that's how simple it is. That's all, 0 j cap. So you do not write that, but I'm just showing it over here. This is just nothing but your 0 times of j cap. It is not supposed to be shown. Great. So what do I have over here? Whenever I have, let's say, vectors like this, I have v1 x I cap plus v1 y j cap plus v1 z k cap. Here I have v2 x I cap plus v2 y j cap plus v3 z k cap, and so on and so forth. If there are many vectors like this, just add their x components, you will get I cap, add their y components, you will get j cap, and add their z components, you will get k cap. That's all. Here you just need to add the terms. That's all. Here you need to add. That's all. Okay, it's very simple. I think many of you will also love this method of adding. It depends from problem to problem, whether the values are given, angles are given, or whether the vectors are given in IJK notation. So accordingly, we will solve it. Now you'll be like, sir, what about subtraction, sir? Subtraction is nothing but addition, guys. So if I have a vector A and I want to subtract vector B from it, so minus B vector will be here. Minus B vector will be here. So the difference or the subtraction, this one, subtraction, which is nothing but A vector minus B vector. The length of that subtracted vector will be given by, again, root of, see what the formula was. It was a square plus b square minus 2ab cos theta. Plus 2ab cos theta. This was theta over here. In subtraction, the formula is almost similar till here, a square plus b square. Instead of plus, you put a minus and you will write minus 2ab cos theta. That's it. Everything else is same. Just put minus sign. That's all. Everybody with me? Clear? So in addition, there is a plus. In subtraction, there is a minus. What is theta? Theta is not the angle between A and minus B. Theta is the angle between A and plus B. That's all. That's all. Thank you, Karthikeyan. Very good. Okay. Similarly, you can do it for, IJK method. Imagine, just an example maybe I can give you. Imagine that my initial velocity is given to be, let's say, 5i cap minus 2j cap, and let's say my final velocity is given to be something like 3i cap plus let's say 6j cap, and somebody asks me find the change in velocity. That means final velocity minus initial velocity. Final minus initial is called as the change. So final is this, initial is this. I will not put a minus sign here because then it does not technically make sense. So 3 minus 5 will be nothing but final minus initial will be minus 2 I cap. 6 minus minus 2 will become plus 8 j cap. That's it. That's the answer. That's how you're going to do it. Okay, great. Some students are confused, sir. Where did that, this come from? So guys, I'll tell you, this is a symmetry relationship. See, if alpha is the angle made with A, beta is the angle made with B, there is nothing special about A and B. A and B could always be interchanged. A and B could always be interchanged, right? There is nothing special. A and B can always be interchanged. So if alpha had B first, then A, then B, then for beta, you will have A, then instead of A, you will put B, and instead of B, you will put A. Just think of it that way. Is that making sense? It's just flipping the variables, nothing great about it. So you can, whenever you know some relationship, for finding the other term which you know is going to behave exactly the same way, you are going to play around with the variables. These are called cyclic relationships. You might have learned that in 8th grade or something. Okay? Is that clear? Understood? Shall we now solve problems? Okay? Great. Here comes the question. Come on, my warriors, try to solve this. Find the vector that should be added to this and this so that the resultant is just a unit vector in the y direction. Thank you, Madala Tejasri. Thank you so much. Glad you guys understood, Vishali. Awesome. Awesome. Hello, Asudha. Awesome, Yogeshwari. So, Rohak, Kanojia, if you are able to understand the concept, you should practice a lot. Attend my sessions, also see my previous year classes, solve those same problems. If you see my lecture, solve the same problems after the class. See if you are able to do it. If you are not, then what's the solution? Try this and then see the solved examples in Tattva, HC Verma, then go to basic problems, then go to higher level problems. Okay, that's what you need to do it. Okay, very good. Chalo, come on guys, figure this out. What should be the correct answer to this one? The vector that must be added to this and this to get unit vector in the y direction. Come on, figure this out. I'll just write down the vectors. So I cap minus 3j cap plus 2k cap should be added to 3i cap plus 6j cap minus 7k cap to some unknown mysterious thing. I do not know what it is. Something I cap, something j cap, something k cap, so that I get a unit vector in the y-axis. Nothing else is there. That means here it should be 0 I cap. Here I should just get 1 j cap, and here again I should get 0 k cap. That is the meaning of unit vector. This is unit vector in the y-axis. Many people saying A, I do not know. Let's see. 1 plus 3 should plus something should give me 0. So obviously this should be minus 4, guys. Will this be minus 4, guys? Everybody? Yeah. Minus 3 plus 6 is plus 3. 3 plus something should give me 1. Oh, that is obviously going to be minus 2. Minus 3 plus 6 is plus 3. 3 minus 2 is 1. 2 minus 7 is minus 5. So here if I put plus 5, I'll get 0. So I think that is option A, of course. Isn't it very simple? It's very logical. It's like I have 2 chocolates. I want so many chocolates. How many more chocolates I need to give? Basic addition, subtraction. Moving on to the next one. 2 vectors having magnitudes 8 and 10 have maximum and minimum values of magnitude of the resultant as. So if I give you 2 vectors, what's the maximum vector you can make using their combination? And what's the least vector that you can make by adding both of them? NCERT is not a good book for theory. It's okay for boards, obviously, but for JEE and NEET, whenever you are studying, you have to go through HC Verma. I've been telling this to many students again and again, but students usually tell, sir, what about that book, sir? That book also has very good theory. DC Pandey. Yes, DC Pandey has also good theory. Yes, that book also has good theory. This book also has good theory. But nothing beats HC Verma, plain and simple. Beat JEE, beat NEET. So guys, please take my recommendation, or you can leave it. or you can probably regret it later. It's up to you. Okay, so I got 2010 in my JEE mains level mock, highest in physics. Woohoo! Very good, Ishan Lohani, 11th student. Very good, very good. He's our pro light student who has been watching all the AI live classes. Okay, option C. So if you have 8 and if you have 10 and if you align them this way, this is the max value you can get in the same direction. So obviously it will be 18. But if you have 8 like this and if you have 10 like this, so the resultant will be just 2 units. Here 2, here is 80. This is the least value. So 18 and 2, that's option C. Awesome. There you go. Very good, Prachi. If you're practicing from H.C. Verma, and when you practice from H.C. Verma, try to understand what Vermaji is trying to build or tell. There are very good questions in H.C. Verma. H.C. Verma sir always wants to convey something via questions. It is not written anywhere, but when you solve it, you'll understand. And one such thing is short answers. So I've discussed all the short answer questions because there are no answers given in my micro course called as short answer discussions for H.C. Verma, both 11th and 12th. Okay, you can watch them. A is 2, B is 4, the angle between them is 60. Then what is the magnitude of the vector subtraction? I just told you, whenever you have to find the subtracted value, it is always a square plus b square minus 2ab cos theta. The minus sign comes. Here, a's value is 2, so 2 square. B's value is 4, minus 2 into 4 into cos. The angle between the two vectors is 60 degrees, so cos 60. So this would become 2 square is 4, 4 square is 16, minus cos 60 and 2 will cancel. Cos 60 is half, right? So 2 4s are nothing but 8. So this will just become 16 minus 8 is 8, 8 plus 4 is nothing but 12. Okay, so I can just write it as 4 3s are 12, so 2 root of 3. That's it, that's the answer. Just check it out. 2 root 3, yep, it is. That's all. Yep. Awesome. Questions come from H.C. Verma or NCERT. Questions neither come from H.C. Verma, questions neither come from NCERT, questions neither come from PYQ, questions neither come from DC Pandey, questions neither come from Cengage, questions never come from any book, bacha. So if somebody has told you or some coaching has told you that solve this book, questions will come 99%, 70% questions are from this book, nicely has just made the video for just gaining views. Okay, so sometimes people just do it for some random thing, you know, for gaining views, and people get fooled into thinking. They think that, oh my god, I will get good marks, I'll just solve these papers, just do these 2 things, you will get 100% marks. So guys, please don't get fooled into all these things. Okay, so it's my job, although I'm on YouTube. Okay, yes, it is a very fabulous book. All right, Nurture batch is enough for JEE preparation and also Pathfinder batch. Yes, Savantika, the combination is the best one. Can you join Pro now? Yes, in fact, I would advise you, Khairu Manjula, to join it right away. Do not delay any further. What is the angle that the two vectors should have so that the resultant is p root 10? I'm guessing that p root 10 is not seen so clearly, but it is p root 10. So how will you add these two vectors? At what angle will you keep them so that the resultant is this much? Well, I know the resultant's formula is nothing but the first vector square plus the second vector square plus 2 into first vector into second vector into cos of angle between them. Probably the best thing to do is substitute all the values and maybe we'll get it. So p root 10, I'll just put it over here, p root 10 is the resultant, and here I will have a square. A square is basically 2p square plus b square, which is root of 2p whole square, plus 2 into 2p into root 2p into cos theta. Great. I think it's better to square both sides, so it will become 10p square is equal to 4p square plus 2p square plus 2 2s are 4, so 4 root 2 p square cos theta. Obviously p square, p square, p square, p square gone, and what happens is 10 is equal to 4 plus 2 is 6 plus 4 root 2 cos of theta. So 4 root 2 cos of theta will be, take that 6 over here, 10 minus 6 is 4, Now I can again see that this 4 and this 4 also cancels, and I'm just left with cos theta is equal to, bring this root 2 below, is 1 by root 2. So hence theta should be 45 degrees. That's it, complete answer. Very good. Is Tattva enough? Tattva is more than enough, but please do HC Verma. HC Verma plus Tattva plus class notes plus assignments plus the revision material. So whatever Vedantu will give you, that is more than enough. You don't need anything else. So that's the reason why you join coaching, guys. So a good coaching is where you get enough material to practice. You don't need to go anywhere extra. You don't need to buy anything extra. You don't need to think about anything extra, because you get complete guidance from end to end. So that is what a good coaching is. So yes, we'll give you all the material. I'm not saying only rely on Tattva, but Tattva plus HC Verma plus, all these assignments and the material and the revision practice class notes, that is more than sufficient. Moving on, next question. If the sum of two unit vectors is also an unit vector, then the magnitude of the difference in the two unit vectors is? Beautiful question. King for entertainment, yes, I do remember you. Yes, from basics. Yes, it will be from basics, bacha. So let's try to do this. If the sum of two unit vectors is again a unit vector, imagine that a hat is a unit vector. I add it to another unit vector to get another unit vector. Unit. All the three vectors are unit vectors. Maybe it will form a triangle where all sides are equal. Think about it. If this is b hat and I get the resultant as r hat, all are unit. That means this side equals this side equals this side. That means it has to be an equilateral triangle. So this is not the correct diagram. The correct diagram should be like this. This is a vector, this is b vector, and this is your resultant vector. Great. Done. So now I ask you, what is the angle between A and B? I need it for the calculation. So come on guys, what is the angle between A vector and B vector? Just put it up in the chat box. Just put it up in the chat box. I do not know, Sudiksha, whether it is A or B or C or D. I'll see. But okay, your answers are locked, Sudiksha and Vaishali. What is the angle between A and B? Prachi also going with A. Let's see. What is the angle between? A lot of people are going to say, sir, it's an equilateral triangle. So obviously, sir, the angle between them is 60 degrees. No, the angle is not 60 degrees. The angle between A and B, actually speaking, is 120 degrees. 120 degrees. You'll be like, what nonsense? I thought this is the angle. No, that is not the angle. Whenever you have to measure the angle between two vectors, ensure that their tails are joined together or their heads are joined together. So imagine you have two vectors. Imagine you have two vectors like this. Then if their tails are joined together, this is the actual angle between them. This is the actual angle between them. Everybody with me? But if the two vectors are here, then their head and tail are joined. So what you do is, you slide the vector till it comes here. You slide the vector till it comes here and then measure this angle. When the vectors are like this, please do not measure the angle. If you notice over here, that's exactly the case. A vector is the red one, B vector is the blue one. You can see their head and tails are being joined. So what you do, slide them till they come here. Now you measure the angle between them. Now won't it be 120 degrees? Everybody? So always slide them and then measure the angle. See if this makes sense. Everybody with me on this? Yes, 180 minus 60. Now, why did I do that? Because the question says, what is the magnitude of the difference between them? A vector is 1, B vector is 1, angle between them is 120 degrees. This is basically your theta. So, the magnitude of A minus B. So, the magnitude of A minus B hat is nothing but A's magnitude 1 square, B's magnitude 1. And then minus 2 into 1 into 1. Here, if you put cos 60, you will get a wrong answer. If you put cos 120 only, you will get the correct answer. That is why that angle is very important. Okay, a lot of students put cos 60 and they get a wrong answer. So 1 square is 1, 1 square is also 1, minus cos of 120 is minus half. So minus minus becomes plus, so it will just become 1 plus 1 plus 1, which is basically root 3. That is the correct answer. So now do we have root 3 somewhere? Yes, option B is the correct answer. See, that's how you get it. AI Live is for, yes, for all the students who would love to, enjoy the entire course at a very affordable price. Some people are not able to afford the live batches, so it's for them, or for those students who feel that, okay, I don't need live batches, I'm okay with, the recorded classes as well, but the interactions are all live, like the class teacher is live, quizzes are live, everything is live, so everything works. Okay, I'm so glad Karthikeyan, and this is the whole purpose of me coming over here, or else we could have just sat aram se and just conducted our regular classes. But I like to interact, I like to teach, I love physics also, and I love teaching, and I like to improve your marks. I like to make you guys a better individual in the next 2 years. That's why I'm here regularly, or else we could have just uploaded the videos and just sat aram se, and there is no need of any interaction then. So that's the reason why we are here. I'm so glad. It makes me feel really good when I hear such things. Okay, so what about this? If a vector A is having a magnitude 8 and it is added to vector B, which lies on the x-axis, then the resultant of the two vectors lies on the y-axis. My goodness. And the magnitude is twice that of B. What is the magnitude of B? Okay, mind blown. But if you start solving it step by step, probably you will get the answer. A vector has a magnitude 8. Let's write down what and all we know. Vector A's magnitude is 8. Vector B is on the x-axis. So B vector is on the x-axis. So it is on the x-axis. The resultant of the two vectors lies on the y-axis. Interesting. So the resultant, basically A vector plus B vector, lies on the y-axis. Interesting. And the resultant's magnitude, so A vector plus B vector, which is R vector, so the resultant's magnitude is twice that of B's magnitude. These are all the given pieces of information. These are like clues. You are Sherlock Holmes. You have to see the clues and remember the laws and try to manipulate and get the final answer. Let's try this out. I'm definitely sure, Khushi, you will be very, very happy, just like your name, in the next 2 years. Just follow, sincerely, practice. I'm pretty sure you will be there. Okay, so what do we do? A vector, I do not know the direction, but with B vector gives me Y vector. Well, sorry, this resultant vector. Let's try to draw the resultant first. Maybe I'll get some clues. So this is my resultant. This is my resultant vector. Okay. B vector is on the x-axis. Interesting. B vector plus A vector is resultant. So think triangle law. Vector plus vector gives me resultant. So I think A vector should be right over here. Somewhere over here. I'm just putting A vector here. See if everybody follows this. See if everybody follows this, guys. I know triangle law. Wherever the tail to head goes, the next tail starts and that's where it ends. So start from the first tail, go to the last head. That's the missing side. That's triangle law. B vector plus A vector or A vector plus B vector, one and the same thing. Great. This angle is obviously 90 degree and I know that A square is B square plus R square. Pythagoras. And A's value is already given to be 8. B's value is B, but R's value is twice of B. So I'm just going to put 2B over here as per the given information. So this will be nothing but 3B square is nothing but 8 square. So B square is 8 square by 3. Naturally, B will be 8 by root 3. That's the answer if that is asked. Let's see. Magnitude of B. Yes, magnitude of B is 8 by, I think, what am I doing, guys? I'm so sorry, guys. I feel very stupid. See, this is silly mistake. Okay, so this should have been slightly different. Okay, so I'll just put 8 square over here and B square over here and 2B's whole square. This should be 4 times of B square. So this will be 5 times of B square. This will be nothing but 8 square. So B square will be 8 square by 5. so technically speaking, B will be 8 by root of 5. That's it. That's the answer. Do we have it? Option D. Yes, it is option D. Great. Great, great. Yes, yes, Vishal. Yes, Grisha. Yes. Very good. Good observation. You guys are awake. Sir, if head to head is joined, Aditya, then you should not use triangle rule, then you should use parallelogram method. So, like I told before, tail, head, use polygon or triangle, one and the same thing. But when you slide it and both the tails are joined or both the heads are joined, then it becomes a parallelogram. So, it's the same thing. It's just a different way of looking at the same question. Okay, moving on to one more question. 3 vectors of magnitude A each are acting at a point such that angle between any 2 consecutive vectors in the same plane is 60. What's the resultant? I'm following you for months, sir. Now I write advanced exams, sir. Bless me. Oh, king for entertainment. All the best, bacha. But please watch my JEE advanced classes I'm conducting for all the 2022 students. Yes, please watch all the advanced mock test questions. I will see you tomorrow also. Yesterday also I conducted a mock test. I'll be seeing you and probably talking to all of you in the days to come. Okay, so one vector, if it is here, the other vector makes an angle of 60 degrees and the next vector basically makes a 60 degree with this one. So 60 plus 60 basically makes 120 degrees. Magnitude wise, all of them have the same magnitude A. So 60 with that, so total angle 120 degrees. So these vectors have to be added. So let's say I call this vector 1, this as vector 2, this as vector 3. Okay, how about I add 1 and 3 first? I just got an idea. How about I add 1 and 3 first? So this is your vector 3, this is your vector 1. The total angle between them is 120 degrees. This is also A, this is also A. Oh, I know what to do. The resultant, I just can slide this. This is as good as saying this is A and this is A because this is 120, because this is 120. So can I not say this is 60 degrees? This is 60 degrees. So shouldn't the resultant of both of them, this is also A magnitude wise, this is A magnitude wise, this is also A magnitude wise, 60. Guys, isn't it going to be an equilateral triangle? Two sides are congruent, and one angle is 60 degree. It has to be an equilateral triangle. So the resultant of them will also be A. So this is vector 1, this was vector 3. So vector 1 and 3 can be combined together as one single vector, making an angle of 60 degrees whose magnitude is A. So job of 1 and 3 is done. Now only vector 2 is remaining. I have to add it with this vector. So vector 2, if you look at it, is basically a vector of magnitude A making an angle of 60 degrees here, and the resultant of 1 and 3, the combined effect, is also of the same magnitude, making same angle. So hence guys, what is the combined effect of them? This was 2, this is the combined effect of 1 and 3 together. All vectors have been considered, so hence this is the resultant, and the resultant will be 2 times of A, twice of A. That's it, 2 times of A. So is that there somewhere? Yes, option A. If you notice, I have not written down any equations. Sir, what is your advice for a student who is wishing to prepare for NEET but the school is not good? Actually, your preparation for NEET or JEE does not depend much on your school. In fact, when I was preparing that too for JEE is much difficult than NEET, right? So I had taken a school which has very minimal attendance. In fact, it did not require 75%. So I did not depend on school or college. Basically, I was dependent on coaching, or basically every student most of the times is dependent on the coaching. So your coaching should be good. Doesn't matter on how your school or college is. So that's how you can crack NEET. Okay, so make sure you're a part of a good coaching, bacha. So 2A is the answer. Oh, we have reached the end of the class, and look at this. This is drop a comment. Yep, notification. So make sure you put up the answer in the comment section. This is your homework question. Solution and answer will be there after the class in the Telegram channel. Okay, and see guys, these are the versions that we have where you can get the best of the best teachers with test series, revision, fortnightly tests, yeah, revision of 11th, 12th, everything done, class notes, PDF, class interactions, feedback, in-class doubt, class recording, scheduled nature. All these things are available and for a very affordable price. In fact, when you use the discount coupon code, be it JEE or be it NEET, you get it for almost like 14 to 13,000 rupees. Even the highest version comes down to, you know, very little cost when you actually compare it with offline coaching, which traditionally charge anywhere between 2 lakh to 5 lakh rupees. The two hostel fees, mess fees, so many other things have to be included. Plus you have to travel. A lot of people forget to add the travel cost or staying cost in an outside city and all of that. So for as less as 14,850, you get the AI live version. The live versions go till 30-50,000 when you use the appropriate coupon code, which is SHHPRO. So this is both for JEE and NEET. You get all the it's like a complete solution. You don't have to go anywhere. You don't have to join any additional classes. Board's syllabus is also covered. We have board revision, board practice, board mock test. Also, although you are joining JEE or NEET a batch. Okay, so that's how it works. There is a link down in the description box. Click the link. You will see it will open up. Okay, awesome guys. So I'm teaching in the AI Live batches. So if you're a part of the English batch, if you're joining the English batch, then you will be seeing me, bacha log. And by the way, let me also show you, this is the way you are going to browse through the playlist. So if you go through the playlist, this is where you will see JEE NEET class 11th. You can see this playlist over here. Just click on this. You will see all the beautiful playlists will open up. If you open on this, you will see the previous year's classes as well. But I have also started arranging things in the individual chapters. Like if you can see, let's say for example, 1D. These are your previous year classes. Okay, now this is this year's class. That also is there, okay, right now. So I'm updating the playlist slowly and you will see like vectors, like whatever is the last year's classes, everything is there. And today's class is also there, okay. So right now you're watching this class, not Arjun Kapoor. Okay, great. So, well, anyways, I hope you guys enjoyed, guys, and make sure you smash the like button. Bye bye everyone. Bye bye King, Madala, Goxder, Yogesh, Vishal, Legend, Prachi, King for Entertainment. Vedantu has offline classes, not offline, it is called as hybrid. So basically it is online teaching only, but you are in a group, you are in a physical classroom, class teacher is also there and the master teacher is on a big screen in front of you. You get that feeling of offline, but a teacher is able to teach in a very effective manner because you are using all the software advantages like quizzes, polls, leaderboards and all of that. Okay, bye bye guys. Bye bye Khushi, bye bye Manikandan, bye bye funny videos. Can you please guide me on what to do exactly? I'm preparing for IOQ but lack the required guidance. Vishal, if you are preparing for Olympiads, then we have a Vedantu Olympiad school. So if you're a part of Vedantu, just get in touch with your master teacher, okay, or class teacher. They will help you. There is something called as the Vedantu Olympiad school. So if you are a part of it, we'll automatically train you. And we also handpick students who are doing extremely well in the tests and will train you for Olympiads also. So Vedantu trains students for Olympiad also. Yes, Pandu rocks and so does all the warriors also rock. Bye bye guys, take care, have a great time, see you again next time. Bye bye, hasta la vista, take care. This was Captain Shreyas signing off.